Okay, now we start the mathematical modeling with Excel. The basic textbook for our class is mathematical modeling with Microsoft Excel, which is written by Eric Norwich and Dean Argenbright. This is the cover of the textbook. This book is a hand-on introduction to modeling a wide variety of applications in Microsoft Excel. Okay. It has numerous tutorials and applications to illustrate how to model and solve problems in Excel. Okay. The first chapter is Introductory Models, which covers Fibonacci numbers and growth model and extended growth model, and comparing different growth models. And second chapter covers dynamical models and difference equations. And the next chapter covers physics applications, including projectile motions. And chapter 4 covers number theory. Chapter 5 deals with the functions and graphing. The theme of chapter 6 is creative mathematics in everyday settings. Chapter 7 covers combinatorics and probability. Chapter 8 deals with finding optimal solutions, and there are appendices. Okay. Today, we start with the chapter 1 introductory model and section 1.1 Fibonacci numbers. Okay. In this section, we will introduce the problem of Fibonacci sequence and also how we will study how to make a mathematical model from this Fibonacci sequence. And also, you will have a chance to make an Excel file, Microsoft Excel file, that models that do simulate this Fibonacci sequence. Okay. This Fibonacci sequence was developed by Leonardo Fibonacci at Pisa in late 20th century and early 13th century. It deals with the population models. Our objective in this section is to expect the number of rabbits at certain period of years when the population growth are made with certain conditions. Okay. Here, rabbit problems. You will find this the growth model, the population model of rabbit from this reference. Okay. Here, it has the basic introduction of the problems and the proof. And all the details of the solutions and applications and generalizations and related problems and references as well. So you can have more information from there. And we start the model, Leavitt problem model with the Excel file here. Okay. This shows how these simulations can be made when we give the conditions such as this. Okay. And when you change the condition, the number of the Leavitt pairs being changed, as you see, and these can be modeled in this way. Okay, you will see how this Excel file was made to simulate the model. Okay. Before you do the exercise, I will explain this Fibonacci sequence model. In the year 1202, the Fibonacci at Pisa became interested in the reproduction of Leavitt. He created an imaginary set of ideal conditions under which Leavitt could breathe and pose the questions. How many pairs of Leavitts will there be a year from now? The ideal set of conditions was following. Rule first, you begin with one male Leavitt and one female Leavitt. These Leavitts have just been born. Second rule, a Leavitt will reach sexual maturity after 1 month. Then the gestation period of a Leavitt is 1 month. Next, once it was reached sexual maturity, a female Leavitt will give birth every month. Next, a female Leavitt will always give birth to one male Leavitt and one female Leavitt. The last rule says Leavitt never die. So, how many male and female Leavitt pairs are there after 1 year, 12 months? Okay. From these given conditions, month 0, at the beginning of the experiment, there is only one pair of Leavitts from the given condition. Okay, there is only one pair when we start of Leavitts. After 1 month, 2 Leavitts have mated but have not given birth yet. Therefore, there is still only one pair of Leavitts. Okay, after 1 month, it's been mature, but not ready to give a birth yet. So total pair is still one. One pair of Leavitts are there after 1 month. But after 2 months, the first pair of Leavitts give birth to another pair. That makes 2 pairs altogether. So after 2 months, this newly birthed a pair of Leavitts started to give a birth. So after 2 months, we have 2 pair of Leavitts. After 3 months, the original pair gives birth again, and the second pair mates, but do not give birth yet. Okay? So after 3 months, the first pair give another birth, but the newly born pairs are not ready to give a birth yet. So after 3 months, we have 3 pair of Leavitts. After 4 months, the original pair give birth again. And the pair born in month 2 is now 2 months after their birth, so they are ready to give a birth. Okay, so the pair born in month 2 started to give a birth. So the pair born in month 3 mate, but do not give a birth yet. So this make 2 new pair of rabbits can be born. So that makes total of 5 pairs of rabbits after 4 months. Okay. After 5 months, every pair that was arrived 2 months ago can give birth. This makes 3 new pair. So we have a total of 8 pair of rabbits after 5 months. Okay. If you see this sequence, we started with 1 pair of rabbits, and after 1 month, still 1 pair. After 2 months, we have a 2 pair. After 3 months, we have a 3 pair of rabbits, and 5 and 8. You may find a rule. You may find a rule from this sequence. Okay. This number 8 was made by adding these previous 2 numbers, and this number 5 was made with these previous 2 numbers, and such and such. Okay? If we graph the number of total pair of rabbits, then we will see 1, 3, 5, 7, etc. It goes. You will see it will grow exponentially like this. Okay. So that's the model that Excel model that you saw in a simulation in here. But if we can think another mathematical model of rabbit birth, okay, with the condition that after some period of time, the old rabbits dies. If we add such a condition, so we make a extended growth model of rabbit pair, then we have another model with the Excel file that shows the simulation of that case. Okay, yeah, this Excel file shows the simulation on 등차 수열 and 등비 수열 and Fibonacci sequence and extended model of Fibonacci sequence. Okay. Okay. First, the general extended model for the rabbit problem with lifetime. Okay. Then we may make a model with these rules. The first, the baby rabbit will be matured after 1 period. Okay. Matured rabbit pair can have a birth after 1 period, and then continuously makes a birth at each period. Third, the matured rabbit will be died after nth period. And every matured pair of rabbits give birth until they dies. If we consider a model with those conditions, then we can make a table like this. When period is 0, then we have only one pair of rabbits, and these are the table for the Fibonacci sequence until we reach it at the death of the rabbit. But when it reaches, so if we give the life time for the birth, then the number of dead pairs will be should be counted, and it should be deducted from the model, and also we should consider they do not make any more baby births since then. Okay, and we will see those models in this Excel file. Okay, suppose before we had the model that we had is this. When k is equal to 1, after one period, and they do make a birth, then we have the regular Fibonacci sequence. Addition, the number of the case term of Fibonacci sequence is the addition of previous two numbers. Okay, like this. But if we extend it, if they give a if a pair of rabbits make a birth of new babies of two pairs, then the number has been increased in this way. If every pair of rabbit makes the birth of 5 pair of rabbits, then it's been dramatically increased in this way. Okay. Okay. When they, but if we add another condition that gives that the rabbit should be died at one period, then this is the table of the remaining pair of rabbits, because a pair of rabbits are matured and give a birth, then dies, and the next pair leaves it, and when they give a birth and then dies, like that. So the number of pairs remaining alive is 1. But if we extend the life period for the rabbit, then it gives the changes. So now we can read the basic Excel files, giving some modification on here by adding a tool such, which is called as a slider here. Then we can make we can generate the table easily, and also it shows us the simulation automatically. So from here we can expect how the number of adult rabbit pairs being changed by making such a small Excel files. So this can be one easy example of dealing with the population model of rabbits by using Excel files. Here, for the same thing. This is we may start from the we may do the similar thing with the more simpler models, like these tables, these formulas. When for the first numbers given after 14th period, how it's been changed can be simulated in this model, like what you have here. Okay, so so if you understand this formula for the sequence, then I will let you know how to make the Excel file that represent the sequence and the equations, and then how to make a table that generate the sequence of those numbers automatically, and then how you can make the graph from the generated data. And after you make one set of those modeling, then how you can extend it with more conditions by adding a slider. Okay. And after that, we will start to analyze what the sequence means from the observing the visualization of those concepts. Okay. Mr. Kyungwon Kim will continue how to make these Excel files and how we made those Excel files by giving the command lines in it. Okay, Mr. Kim, you may start to how we made the Excel files from here.